Alright, question 7 of the mensuration series. In the diagram, square ABCD has sides 5 cm, okay? And the shaded region, as you can see, is enclosed by the arcs of two circles with centers A and C respectively. So let's look. There's a center A, and what is this circle? If we see, this circle is if the center of the circle is A, then this is the arc we're talking about, right? This is actually the arc. And this is actually the quarter circle. And then we can see on the other side, if this is the center on C over here, then this is the arc we're talking about, with this being the other quarter circle. So you can see two quarter circles, one outlined in blue, one outlined in yellow. And right now, let's just try to analyze what we're looking at here. So if this, now I've been saying this is a quarter circle, but actually how do we know that? It's because this is a square, and therefore this must be 90 degrees. Every corner must be 90 degrees. And if this is 90 degrees, then this definitely has to be 1/4 of a circle, because you're cutting out 90 degrees worth of it, right? And it also tells me that, okay, this is a quarter circle, then what is 5? 5 is not just the length of the square on one side, it's also the radius of this circle, right? Of this big circle, of which you cut out just a quarter of it. So we also have the radius of it. So what do we know? We can just try to apply the formulas that we know. So we know that the area of a circle, let me just label it like this, is given by pi r square. And so the area of a quarter circle must be pi r square divided by 4, since as we've established, this is 90 degrees. This is also 90 degrees. Okay, and what else do you know? We can also, well, know it's a square, right? I mean, they told us it's a square, and so the area of a square, let me just write it like this, is known to be, if we call this, well, in this case, this is actually r, right? Because this is also r. It's the same r. So if I'm going to write it this way. It's going to be the area of a square in this case is r times r, which is r square, right? Area of the square. And we eventually want to end up with this middle section. So let's think, what can we do? What if we said that we have the area of the square and we subtract away the area of a quarter circle? So, and this comes from playing around with just the two formulas that you know, and you just play around and say, what can I do? Can I take one and subtract the other? So if I have the area of the entire square and then I subtract away this area, what am I left with? I'll be left with, if I just label, I'll be left with this area, right? You take the area of the square, if I just write it here, area of the square, subtract away the area of the semicircle, right? And what you're left with is just this section. So if we can find that section, then we know that that section is also the same area as this section, right? And so once we found this, we also found this. And then we can say that the area of the middle section is simply area of the square, subtract away this section, subtract away this section. So just take time to look and appreciate it. And then once you know, we can jump right into it. So we can say, what's the area of the square? Area of the square is simply 5 square. And we subtract away the area of the semicircle, which we've seen is simply pi, and r is 5, so 5 square over 4. And so Now, just bear in mind, we're solving for this area. Okay, and so let's just plug it in. Now, they say pi is 22 over 7. So this is going to be 25 subtract 22 over 7 times 25, because 5 squared is 25, 4. And this gives me 75 over 14. I'm leaving it in fraction form. Okay, so this is also going to be 75 over 14. And then finally, I can solve for this part, which is the area of the circle, which is 5 square. Subtract away 75 over 14. Subtract away another 75 over 14. And what I get is 100 over 7. And that is the area of the shaded region. And since it's cm, you can say this is cm squared. There we go.